Fluid coding and AI. Today we are doing a benchmark reality check on GPT-5.6 Sol, Terra, and Luna using Datacurve's DeepSWE v1.1 leaderboard. Sol is on top, Terra is the cost surprise, Luna is closer than a cheap model is supposed to be. The question is not whether one model scored a few points higher on one public benchmark. The useful question is, if you are building a coding agent, which model should you route to, how much reasoning should you buy, and when does the leaderboard stop being a migration plan? By the end, the answer should be practical. What DeepSWE says, what it does not say, and how to test Sol, Terra, and Luna on your own repos. DeepSWE matters because it is trying to avoid the usual coding benchmark trap. The tasks are original. They are long-horizon software engineering tasks, not tiny patch lookups. They span 11-13 tasks, 91 repositories, and 5 languages. And the verifiers are behavioral. A model does not have to match the reference implementation line for line. It has to make the software behave correctly. That is a much better signal than, did it memorize a public patch? DeepSWE v1.1 also tightened the harness. All models are run through mini-swe-agent for consistency. The agent commits a patch, then grading happens in a clean, isolated verifier container. That matters because agent benchmarks can get weird fast. If the runtime is dirty, if dependencies drift, or if a model can infer the hidden solution from Git history, your score becomes less about engineering and more about benchmark archaeology. Here are the headline v1.1 results. GPT-5.6 Sol at max effort leads with 73% pass at 1, plus or minus 3 points. Average cost is $8.39, with 60,000 output tokens and 61 agent steps. GPT-5.6 Terra at max effort is 70%, plus or minus 3, at $4.95. GPT-5.6 Luna at max effort is 67%, plus or minus 4, at $3.03. Here is where my expectation changed. If you only look at rank, Sol is the story. But if you are paying for agent runs, Terra becomes the plot twist. Terra is 3 points behind Sol on the leaderboard, inside a small enough band that you should not treat it as a clean knockout. But Terra's average cost in this run is about 40% lower than Sol's. That is not a footnote. That is the budget meeting. This is also where we need to be careful. Claude Fable 5 at max effort is listed at 70%, plus or minus 4, with an average cost of $21.63. GPT 5.5 at xhigh is 67%, plus or minus 6. So yes, Sol leads this table. But the nearby models overlap enough that Sol destroyed everything would be a lazy read. The better read is, Sol has the edge in this harness and the cluster is tight. The supporting numbers are useful too. Sol used 60,000 output tokens and 61 steps on average. Terra used 72,000 output tokens and 76 steps. Luna used 73,000 output tokens and 102 steps. That suggests Luna is not magically doing the same work with less effort. It is cheaper per token, and it takes more agent steps here. For high-volume maintenance, that may be fine. For expensive human review loops, extra wandering can still cost you. OpenAI's own model docs line up with that interpretation. Sol is positioned for complex reasoning and coding. Terra is the balance point between intelligence and cost. Luna is the cost-sensitive, high-volume option. All three list a 1.05 million token context window, 28,000 max output tokens, and reasoning efforts from none through max. So the product shape is not one model replacing another. It is a routing problem. One trap: the DeepSWE top entries here use max reasoning effort. That does not mean max should become your default setting. OpenAI's migration guidance says to set reasoning effort intentionally, reserve max for the hardest quality first work, and compare max against xhigh, which is exactly how I would test it. If max buys one more pass but doubles latency or cost, that may be worth it for a production outage and silly for a dependency bump. The docs also point teams toward the Responses API for reasoning, tool calling, and multi-turn workflows. For GPT-5.6, pricing is tiered. Sol is $5 per million input tokens and $30 per million output tokens. Terra is half that. Luna is $1 in and $6 out. But agent runs are not just raw input and output. Track cache tokens and cache write tokens. Cache writes cost a premium, while cache reads keep the big discount. If you ignore that, your eval spreadsheet will lie to you politely. There is also safety context around GPT-5.6. OpenAI's preview system card classifies Sol, Terra, and Luna as high capability in cybersecurity and biological and chemical risk, and below high in AI self-improvement. That is serious. It is not a reason to turn this into a cyber panic thumbnail. OpenAI also says Sol and Terra did not reach the critical cyber threshold in the tested setting and did not carry out autonomous end-to-end attacks against hardened targets. Now the caveat that saves you from a bad migration. DeepSWE is one benchmark with one fixed mini-swe-agent harness on public active repositories. That is valuable because the comparison is controlled. But your production workflow might use Codex CLI, Claude Code, Cursor, a custom tool server, a different approval model, or private code with very different failure modes. So DeepSWE is strong evidence, it is not universal truth. The migration checklist is straightforward. Pick 30 to 100 representative tasks from your own repos. Pin starting commits and dependency versions. Use the same harness, tools, timeout, and prompt when you are comparing models. Then run a second pass with the agent scaffold you actually plan to ship. Grade committed diffs in a clean container. Record pass at 1. Cost, input tokens, output tokens, steps, elapsed time, cache behavior, and retry success. Here is the practical routing rule. Use Luna when the task is cheap to verify, repetitive, low risk, or high volume. Use Terra when you need strong general coding agent performance and Sol is hard to justify on every run. Use Sol when the task is ambiguous, high value, correctness first, or has already defeated cheaper attempts. And do not route by vibes. Define thresholds before the eval. For example, Terra becomes default if it is within 3 points of Sol and at least 25% cheaper on your tasks. My read is this. DeepSWE v1.1 suggests Sol is the leader in the standardized coding agent harness. Terra is the efficiency story. Luna is close enough that high-volume teams should not ignore it. But the smart move is not to crown a permanent winner from one leaderboard. The smart move is to build a small repo-agent eval, test max against xhigh, track real token costs, and route by task value. That is how a benchmark becomes an engineering decision. If this helped you turn a leaderboard into a real model selection plan, like the video and subscribe to Fluid Coding and AI.